Okay. Uh, okay. The module 4, it is Bayesian learning. Most of your, before going to this one, this particular algorithm, we'll see the introduction part of it and where exactly we are using this learning algorithm. Okay. Basically, right away in the textbook, what they have done, they started with the theory and formulas and all, and it's very difficult for us to understand also sometimes. Okay. So that's why we'll start with the basic one, and then we'll see the application, then we'll go into the depth of your theory part. Okay. So these are the contents like introduction and Bayes theorem and Bayes theorem and concept learning, maximum likelihood and least square error hypothesis, maximum likelihood hypothesis for predicting probabilities, minimum description length principle, and Navy Bayes classifier, and Bayesian brief network, and EM algorithm. So these are all the small topics which we have in your module 4. So the first question here is that what is Bayes theorem? Okay. This Bayes theorem is started with the English mathematician Thomas. Okay. Thomas Bayes. He has done some research in decision theory. Okay. Decision theory. This is one of the field which we are using in research. Okay. And that too in a machine learning. It is a decision tree. Okay. Or decision theorem which is used for prediction certain objects. Okay. It is having a basement of probability concepts. It is having a basement of your probability concept. So he has done some research on decision theory. Based on that decision theory, they have implemented in a machine learning. Okay. So that is a first point. In second point, he says that a theorem is widely used in machine learning. Most of your decision making algorithm, if you take it, the best algorithm which we can implement is Bayes. Okay. Which is very simple, effective way to predict the classes with the precision and accuracy. Okay. It will be having a more precision and accuracy. Okay. Calculating the conditional probability. It is used for calculating the conditional probability. Okay. For most of your machine learning applications. Okay. Under that, the best version which we are using is Navy Bayes. Okay. Navy Bayes classification algorithm, which is used for in machine learning applications. What is this having a importance? Reduce computational time. Okay, reduce computational time. That is very important, and also the cost. Okay, so this is how the theorem came into the existence. The next question arises that why we have to use this one in a machine learning, why they are giving a more importance in this machine learning? Because as I said, it is determine the conditional probabilities. Okay, that probability or a particular event occurring iteration times. Okay, and if you want to deal with the complex data, okay, if you want to deal with the complex data, and if you have a more number of data, and you need a accuracy over there, because you keep in mind whenever you are dealing with the complex data and a more number of data, okay, there the accuracy is very less. But when you are using this BT algorithm, I call it as this as a BTA, okay, in short BT algorithm, you will may get accurate results, okay, and prediction also very accurate, okay, prediction also it is very accurate. That's why we go for BTA algorithm. I have collected few examples here. Okay, suppose this BTA algorithms comes under supervised machine learning, SM, that is supervised machine learning algorithms. Okay, supervised means I will tell you in short. Okay, there are in machine learning you have unsupervised machine learning algorithms and supervised machine learning algorithms, and also reinforcement algorithms. Okay, these are all the three main classification of your machine algorithms. Okay, but if you go for BTA, it comes under supervised machine learning algorithms. What is supervised? Supervised means for your machine, it may be computer, it may be laptop, or it may be your mobiles, whatever if you take it, you should pre-train the data. Okay, you should pre-train the data, and every time it has to be updated. In the class we took it a lot of examples on this one. Okay, so BTA will comes under a category of supervised machine learning. Okay, supervised machine learning. So under that you have like you have ice creams. Okay, so you have ice creams which you will be having a brainstorming, or you are going to have a network which is going to classify. See, here you can see easily, that I have mixed the data. Okay, you have this chocolate oriented ice cream and cone oriented ice cream and stick oriented ice cream. It is having a mixing here. So if I give this mixed data or an object, okay, to your network, okay, it classifies according to our requirement. So there we apply this BTA algorithms which need accurate output. Suppose in your class I will be fixing your face recognition camera with algorithm. Okay, so Pawan is entering, Padmashri is entering, Hemant is entering, Rahul is entering, Sushma is entering. So your camera should have a capability to make a decision in such a way that it classifies the faces and name it or label it properly. Okay, there your base algorithms will come into the picture. We have a lot of algorithms, classification algorithms, decision making algorithms, but as I said, you need a accurate output, and you should reduce the cost, and prediction also it should be nearer to the 100%, then we'll go for BTA. Okay, I hope you understood why the importance of this theorem in come into the machine learning. Then I have collected a few examples like you have Gini regulatory network, like your DNS classifications, and online you are going to use your scanners, PDF scanners, merging scanners, PDF merging, PDF classifications. Okay, so there also you will be having your this network. Then in medicines they are using, then they are using in a bio monitoring systems, they are using in the information retrieval That is very important. Information retrieval algorithms, if you take it. So this is the best network which they are using in the world. Then you have a semantic search. You have a image processing. You have a spam filters. You have a turbo codes. You have a system biology. So if you see, wherever you go, whichever the field you go, this particular algorithm is implemented. This is only 10 I have collected. Okay, but it has a huge collections of your data. Applications are there. Okay, in daily life we are using PDF, because every time if you see the PDF online or editing part, classification part, everything you are doing, who is doing this particular work background? By this particular machine learning algorithms only. Okay, I hope you understood this first example and a second example, because this is the best example you can understand. You have mixed with all different ice cream flavors, but it's very difficult to classify at this stage. When I give it to the network, okay, when you give it to the network is nothing but, in previous module we have saw that how the network is designed, okay, like ANN. Okay, so it gives you proper output by after classifying. Okay, so basically these type of algorithms also used in crowd prediction andre eno. So they will be using this particular algorithm to find a terrorist attack activities. Okay, so there we have to classify, because you will train your supervised learning system to find a particular person's face, and I'm giving a data of huge crowd. So your system should have a capability to classify the people separately and the face which is the terrorist or any unknown person you want to find it. It will give you proper output. Same thing, many of the projects ನೀವು ತಗೊಂಡಿದ್ದೀರಾ ಕ್ಲಾಸಲ್ಲಿ. Okay, you have seen the projects of machine learning. So there if you go classification ಅಂತ ಬಂದಾಗ, just try to use this particular algorithm which may give you a computation time also very less, and accuracy is very good, and it is a cost effective. Okay, cost effective is very less. Then I have also collected in the present scenarios. In the present scenarios, COVID is the very booming topic everywhere. Adralli we have variant now, COVID 1 version, 2 version and 3rd version also it came. So in the biomedical sector, if you have a huge crowd of data, you believe or not, if you go for NDTV app, as I said in the previous classes, the classification of the state wise, this classification of the area wise, the classification of your country wise, they are doing properly. They are plotting the graph properly. Why? Because they have a machine learning algorithms. So here you can see like you have a different network for your machine learning algorithms. Like you will be using a deep learning, you will be using a convolutional neural network, other algorithms, traditional algorithms, artificial neural network, previously we have saw, and applications like COVID-19 diagnosis and propagation tools, decision support systems, gene sequence. So it's very difficult. We have to understand the gene sequence of COVID or a virus, how they are doing. Based on that, they have produced the drugs for us now, vaccination for us now. Okay, there also please understand how important is the classification is. Okay, when you come for deep learning, hybrid deep learning, hybrid means it's combination of two variants. so there also you can see Bayesian based sequence or networks they are using, CNN and SVM support vector machines. Okay, so if you see these examples, we can understand how the classification can be done, how these people are analyzing and they are plotting in Karnataka this much, in South India this much graphs, how it is transitioning, how they are going to calculate. They won't monitor, right? Just they take a data and feed it into the algorithm and it automatically classifies this is the variant, this is a variant, this is the variant output. Okay, so there also we are using a BTA algorithms. Okay, and also I have collected one of the examples from IEEE paper here. So here also you can see like we'll be having a input cancer images. So cancer images, any type of cancer images, if you take it as a input, okay, which is given for your morphological features, okay, which is feeding into your morphological features. In a morphological features, we have a dilation and erosion, two types of features, which gives you a lot of data for us. So like area is one of the parameter in a cancer, perimeter of it, maximum radius, minimum radius, elongateness data, equidiameter, entropy, like that. All the different attributes which you have collected from your cancer image is fed into the BNA. Okay, with BNA we have a mutual information, so the correlation between your data, Kullback algorithms, that gives you proper network performance. Okay, proper network performance. So this is how where you can have your BTA algorithms, or also we use in short BNA analyzer or analysis system. Okay, now I hope you got it idea about how this particular algorithms are very helpful. See, not only keep in mind, it is not only use it for only biomedical sector, it can be used in sensors. You will be connecting your sensors. Don't keep in mind that if these algorithms cannot be implemented for hardware, sorry, 100% you can use these type of decision making algorithms based on your sensors also. Soil moisture monitoring systems, finding the sand nutrition contaminations, okay, in a farmer or agriculture sectors. If you take it, you can do it. In a food sectors, if you take it, okay, you can classify. Suppose I'll give one more example here. You have a bowl of fruit, which I have given a fed into your one machine, which will find out that which fruit is spoiled. It takes all the image part of the bowl, okay, and it will try to give you classification properly. This is spoiled fruit, this is good one fruit, this is initial stage of a fruit. So like that. Okay, 1 minute. sorry for the interrupt. Okay, so like this you can have your different classifications for your BTA algorithms. So in future also, if you are in switching into the industries, most of the data they will give it will be in the form of unstructured data. You want to put it into the structured data, so BTA can be easily done. Got it? So this is way I can give you a lot of examples. As I said, we can give a lot of examples on this one. Okay, then that is only I have given a introduction. It is one of the this method is one of the study of machine learning in two different regions. We have BT algorithm for two different reasons. One is calculate the explicitity of your probability for your hypothesis. So we have seen a lot of problems on hypothesis in the first module also. So there we go for these type of algorithm, which is very true practical you can apply. And the second reason is provide useful perspective of understanding other learning algorithms also. Okay, some manipulations you want to do. So this is the Navy Bayes classifier is the best algorithm you can implement. Okay, then features. What are all the features we have in BLM? We'll see. So each training examples incrementally decrease or increase the estimated probability that says that this is a correct, this is a bad. So such facility or features are there in your BT algorithms. So this particular feature gives you very flexible to apply in all the applications, which I showed you in the previous. The second one, you should know priorly about this algorithm, how it works, how the probability works. Okay, like as you can take it one case here, prior probability for each candidate hypothesis you should know. Then second says that the probability distribution over the observed data for each possible hypothesis, that also you should know. So why this example, like we took it in first module, example like sports. You know already that if it is sunny I can play the sport. If it is winter, suppose example, I can play. But when come for rainy, I am sure that I cannot play for that. But still the probability occurs that you observed that data, and based on that data you are feeding into the BTA and you are taking the decisions, or you are going to classify according to the situations. Okay, so I hope you understood the prior knowledge. You should have a prior knowledge on this one. Then these methods accommodate hypotheses that make probabilistic predictions. As I said, this is the best method for your prediction. Okay, and also you have a option of, if you have a new instances, if you have in between new instances, it's very easy to feed into it and try to predict it. Okay, so that is also you can do it with the BT algorithms. Okay, so and also I told you it's a best practical algorithm. It is a best practical algorithm. Okay, I hope you understood these things. Okay, what is a BT, why it is BT we are using in machine learning, and we took examples of it. and this is also one of the example we have discussed. Okay, and also we took it the present scenario, what is happening in the world. Okay, so why exactly, where exactly, how exactly these people are using this algorithm to classify the even genes, DNA structure of your DNA structure of your corona or COVID. So these things, it's very easy. And also we took example of cancer images. Okay, and also we have discussed about the features of your BL methods. Okay, so I hoping that you have understood this particular concept of BL. Okay, then you have advantage, but also you will be having a difficulties also, practical difficulties. What it is, we'll see now. One practical difficulty in applying BM method is required what? Initial knowledge. I'm stressing more on it. You should have initial knowledge of where exactly you are applying and what is the probability output. If you don't know the probability of output well in advance, the total estimation cost can vary. Okay, so this is the first practical difficulty. Right away I cannot use it practically, you keep in mind. Second practical difficulty is significant computational cost. So you may ask, sir, why, sir, it is just an algorithm, sir, why the cost may vary, why the money will come into the picture here? For your kind information, these algorithms you have to implement with sufficient machines. Okay, you cannot right away execute in a lower end systems. It may give you the result, but it's very difficult to compute with the time. So that's why you have to invest a lot of money for the computational system. Okay, so that's why when you go for practical of your BTA algorithms, sometimes it gives you 90% advantage, means 10% disadvantage also it will be there. Okay, then theorem. So we have talked about the everything. So in sometimes they may ask you in the exams with the write about this particular BT theorem. Okay, so let's see this one. So BT provides a way to calculate the probability of a hypothesis based on the prior probability, the probability of observing various data given in a hypothesis, and the observed data itself. See, there is a lot of difference. Observing, observed. Observed means already prior knowledge you should have that one, and observing means the second time which you are feeding the data. So these things are very, very important. It gives you a lot of marks for you in the exam, these points. Okay, I hope you will remember. Calculate the probability of hypothesis based on the prior probability knowledge. Okay, and also observed data itself. Okay, so this is about the small definition of it. Then by using this, we have to know the notations. We should know the notations here. What are the notations we have to follow here? So P of H. So P of H represents prior probability of H, reflects any background knowledge about the chances or change of your H is correct. Then P of D. So P prior probability of D, probability that D will be observed. What is D here? Data. Okay, data. Then P of H with D with a H. So it says the notation that probability of observing D given a word in which H holds. Which H holds, that is very important key point here. Then you have a probability first priority with a H. Okay, H and a D. So here what it reflects? Confidence that H holds after D that has been observed. Yeah, yes or no? The prediction when it comes, classification if it comes, the confidence level should be proper. That is there in your BT. Okay, I hope you will remember for this for long term the notations which we are using in a BT algorithms. Then based on that we have a theorem. What is that? BT is the cornerstone of Bayesian learning method because it provides a way to calculate the posterior probability from the prior probability together with P of D and a P of D and a H. Okay, so this particular theorem statement is put up in the form of formula. Okay, P of H with a D equals P of DH into P of H divided by PD. So these notations are very important. P of H, prior probability of H, PD, the probability of D, that is a data, and D and a H, observing D, observed data. Observed, both are very important. Okay, based on that this formula has been formed or a theorem has been formed. Then you have PH with the D increase with the, understand properly, PH with the D increase with the H and with P of DH according to the BT theorem, increasing. Okay, this part is considered. When come for decreasing, if P of H with the D decrease as PD increase. What is PD? What is PD represents? Data. As I said here, data, prior probability of data. Okay, if this parameter is decreasing means your PD is increasing because more probable it is that D will be observed independent of your H and have a less evidence D provided in support of H. So it may be confusing. I will put it in simple way. You have algorithm, you have trained the Pawan phase for a particular thing for first year, but suddenly in between second year or third year you will take the Pawan phase and try to feed it inside. The probability of understanding by that classification of algorithm may vary. The computation may decrease. The computation decreases, the accuracy decreases. You cannot predict properly. Okay, so this is how what we can go for probability theorem. Okay, I will stop it here. We'll meet at 11 o'clock once again. Okay, and we'll try to complete off some more topics. Okay, I'm hoping that you have